And welcome students to our final lesson on text files. Really quickly, let's discuss things on path names, nested constructor invocations, and system in, system out, and system.error. So getting started here with our multifaceted lesson today, let's just kind of really cap on file names. So when you're giving a file name as an argument to a constructor for opening a file in any of the ways that we've discussed, whether you're using the scanner class or the buffered reader, you may use a simple file name, which is assumed that the file is in the same directory or folder as the one which the program is from, which is typically what we've done so far. Now, we can also use what's known as a full or a relative path name, such as c:\program file / ... that would be a full path name. So a path name not only gives the name of the file, but also tells what directory or folder the file is in. Now, full path name, as the name suggests, is a complete path name started from the root directory. So, for example, if it's on the C drive, or if it was like on a, let's say, a flash drive, it would be whatever the name of the flash drive is. Let's say it's F, so F:// yada yada yada. Now, relative path name gives the path to the file starting with the directory that your program is in. So let's say that your program's in, let's just say it's in a folder called project, and inside of that project folder is a subfolder that says text files, and then inside that folder would be all the relevant text files that you would need. Maybe that folder is called logs, because a lot of times you do have like logs that are generated. So you might have it point to log / the name of the log, and that would be where the program would be looking. It doesn't need to do the full c:/ because it's going to move inside the project directory, but it needs that relative path name so that way it can know, hey, I have to look a little more specific. Now, the way that you specify path names depends on your particular operating system. Windows-based operating systems, this is slightly different from that of Unix. Since we're primarily working in a Windows environment, we're going to look at that one. Unix is really not that much different. It's just pretty much how the slashes are arranged. So if we talk about creating the path, the first thing you know is that Windows uses the \/ So that's the big thing to know here in path names. If you ever had to path it out, you'll see that it's like that. So a quick example of a Windows path name was something like c:/ data file / good data / data.txt. Now, if this was in a Unix system, you would have it with the slashes facing the other direction, probably on the root directory. Now, if you wanted to create a buffered input stream connected to this file, we'd use buffer reader input stream with new buffer reader, new file reader, c:/ data file / good data / data.txt. And you'll notice that there's a doubling of text or slashes here in comparison to the path name. And you'll note that that is because, remember, Java, if it just sees a slash paired next to a character such as /d, it registers that as an escape character. Java's going to look at it and say, well, what do you want to do with this? So instead, we have to use the //. And though, of course, we have to where we use \/ in a quoted string, this problem does not occur with path names that are read from the keyboard. So if you were to type it in, Java is smart enough to realize that, hey, you actually mean this. Now, one way, of course, to avoid escape character problems altogether is to always use Unix conventions when writing path names. And I'm going to give an example of how you would do that with Windows. Now, a Java program will accept a path name written in either Windows or Unix format, even if it's run on a computer with an operating system that does not match the syntax. Java recognizes how to adapt that so that way you can actually still use it. Thus, an alternative way to create a buffer reader input stream connected to a Windows file, c:/ data file / good data / data.txt, is through the following. Buffered reader input stream equals new buffered reader, new file reader, c:/ data file / good data / data.txt. And you notice these are all forward slashes, whereas these before were backslashes. All right, next item of the topic is the nested constructor invocations. Now, expressions with two constructors such as the following are common when dealing with Java's library of I/O classes. New buffered reader, new file reader, original.txt. And when we see two constructors, you'll notice we have the buffered reader constructor followed by a file reader constructor. Now, this is a manifestation of the general approach on how Java I/O libraries works. Each I/O class serves as one or a small number of functions. So in order to obtain full functionality, you normally need to combine two or more class constructors. In this case, the example we gave was the buffered reader and the file reader. For example, in our previous code, the object new file reader, original.txt, establishes a connection with the original file, original.txt, but only provides very primitive methods for input. Whereas the constructor buffer reader takes this file reader object and adds a richer collection of input methods. So buffer reader allows us to do a lot more. In these cases, the inner object, such as new file reader, original.txt, is transformed into an instance variable of the outer object, such as buffered reader. All right, and to wrap things up today, we need to discuss system in, system out, and system err. All right, the streams system in, system out, and system err are three streams that are automatically available to your Java code. And we've obviously already been using system.in and system.out. You know, for example, system.out.println, scanner keyboard equals new system.in. System err is just like system.out, except, well, it has a different name. It generally has a different function, though. So, for example, both the following statements will send the string hello to the screen, so the screen receives two lines, each containing hello. System.out.println hello, system.err.println hello. Now, the output stream system.out is intended to be used for normal output, so don't change anything of what you've been doing. We're just going to keep using system.out. Like I said, system err is a little more has a little more different functionality, and that has to get into redirecting of output. So having two different standard output streams can be handy when you redirect output. For example, you can redirect the regular output to one file and redirect the error messages to a different file. So let's say you have you want to create two text files, for example. One is called like output.txt. The other one would be called errorlog.txt. You could use the system.err to write to the error file. Now, Java allows you to redirect any of these three standard streams to or from a text file or any other input-output device. And of course, there's some static methods, set in, set out, and set err of the class system. So, for example, suppose your code connects the output stream or a sys stream or of a type to be specified later to a text file. You can then redirect the stream system err to this text file as follows: system.set err stream. So then if the following appears later in your code, system.out.println hello from system.out, system.err.println hello from system.err, then hello from system.out will be written to the screen, but hello from system.err will be written to the file connected to the output stream, err stream. Now, a simple program illustrating this, of course, is shown in our redirection demo. Now, before we go look at the demo, just really quickly, I just want to kind of wrap this up here with a couple things. Note that the arguments to the redirecting methods must be of the type shown in the following heading, and that these are classes that we do not discuss in this course. Public static void set in, output stream in stream. Public static void set out, print stream out stream. Public static void set error, print stream out stream. None of the input or output streams we constructed in our previous programs are of a type suitable to be an argument in any type of these redirection methods. Now, the course constraints and what we can cover in this course, the scope of it, kind of keeps us from really exploring any more details on the stream classes that are suitable for producing arguments of these redirection methods. However, we can look at the redirection demo as a model to allow us to decide whether we want to redirect either system or system out to a text file of our choice. So if we look at that text file here, or the demo, we can see we have a print stream right here setting to null, and of course it has to be outside the try block. And the try block just says error stream is new print stream file output stream error messages.txt. It has a catch block for file not found. We're going to use system error stream. We have a system.err println hello from system error, system.out.println hello system out, and error hello again from system error. All right, and then we close the stream. So you'll notice if I run this program, we only get hello from system out in our console. However, what we've also gone and done is generate a text file. So if I go here to my workspace, right, and redirection demo, here's my error messages.txt, and you can see it says hello from system.err, hello again from system.err. So you can see what this does is allows us to put two different kind of outputs. So this would be a good way, for example, of looking at if, let's say, the system.out is a way of you communicating with the user, but if you wanted to keep a log of something, then you could use the system.err in order to handle that. All right, and that's going to wrap it up for today, folks. So until next time.